everyone, and welcome to our sixth Share Your Green Design Masterclass. Share Your Green Design is a digital ecosystem of exemplary case studies, research, methodologies, and ideas that showcase sustainable architectural design from around the world. Our mission is to substantially reduce the industry's carbon footprint by providing architects, engineers, and all construction professionals with the knowledge that they need. Masterclass is a space where we invite top experts on very specific topics related to sustainability in the built environment, decarbonization, health and well-being in buildings, and much more. Today, our special guest is Anna-Marie Fallon. Anna-Marie is an associate director, architect, and certified passive house designer at Architects, and one of the UK's leading experts on passive house design. She has successfully delivered the award-winning and UK's largest passive house residential scheme, Agar Grove. She has involved in quality and technical design reviews for the UK's largest passive house secondary school, Harris Academy Sutton, the UK's first passive house plus school, Hackbridge Primary, and the UK's first passive house plus office, Bicester Eco Business Centre. Anna-Marie also brings expertise in EnerFit, the passive house standard for retrofit, having delivered Archetype's first EnerFit in 2017 and the first EnerFit in Ireland in 2011. Anna-Marie worked closely with the Scottish Futures Trust developing the new cost metric for Scotland's learning estate, as well as contributing to new energy requirements for Scotland's education sector, linking capital funding to operational energy performance over a 25-year period. In addition to her work at Archetype, Anna-Marie is part-time teaching fellow at University of Bath and also visiting Part 3 external examiner for the Technical University of Dublin and the Ballet School of Architecture at UCL in London. During this masterclass, Anna-Marie will be speaking about Scotland's first passive house primary school, Riverside Primary. She will share with us the challenges and lessons learned, as well as the feedback from the occupants and some post-occupancy monitoring. As usual, we will have a Q&A session after the presentation, so please post all your comments and questions in the chat on whichever platform you're streaming from, and we will go through as many as we can. As a last reminder, we'll be recording this session and we'll post it later in our channels for your review. So over to you, Anna-Marie.
Thank you. I'll just take 1 second to share my screen. So I'm on full screen now. Everyone can see that?
Yes.
Okay. All right. Okay. Thanks. Thank you, Bethania, for the introduction. I'll get straight onto it to try and get through what I'm presenting today. So, hi everybody. As I've already been introduced, I'll just get straight into the slides. So I wanted to talk a little bit today about Scotland's first passive house primary school, Riverside Primary School, for Perth and Kinross Council. And I'm going to run through some lessons learned, the design process, how we achieved targets, a little bit on the post-occupancy performance of the building as well, the limited amount we have so far, and the insights that we gained from the projects. So just as a quick overview to Archetype, we're a 38-year-old practice now, and we've worked across a variety of different scales and typologies of projects over the last 15 years with a specific focus on passive house. And I think, as you can see from some of these images, the quality and kind of visual output of the buildings we've worked on there's a great variation to that, and passive house does not constrain us. And there's many kind of great teams out there now working on lots of passive house projects at large scale, demonstrating that across the UK. We've also paid a lot of attention to the lessons learned in our own projects in the past. So evolving passive house schools in particular through POE, post-occupancy evaluation, or building performance evaluation, starting with the very first wave of sustainable, naturally ventilated buildings that Archetype designed in the early 2010s, right through to the very latest schools, and trying to implement and avoid any issues or lessons learned around use, design, commissioning, etc. In those periods, and also dealing with new issues that are inevitably always come up. So we have a good data bank of lessons learned from various projects. And of course, the challenge of designing educational buildings is that they're occasionally have high occupancies in certain areas. There's certain compliance requirements wherever you are in the world for education spaces, and the scope and briefs can vary wildly depending on what type of pedagogy and teaching curriculum you're working with. But most importantly for us, we want to create a comfortable space that teachers can teach in, that they don't need to worry about the environment they're in. And you can see that this was a study, a graph that we've had from 2014, where we monitored a 1970s school that was very poorly insulated, poorly ventilated. And we can see that the CO2 levels indicating indoor air quality are quite high through the actual occupied day, in particular in the winter here when the windows wouldn't be open. By comparison, we can see that with Passivhaus, so this is one of our Wilkinson Primary School that was completed in 2014 and monitored in the same year, had much more healthy levels of CO2 and much more enhanced indoor air quality, and also using an awful lot less energy, of course, with Passivhaus. But I think to emphasize the indoor air quality benefits here. And from a kind of a qualitative point of view, we have lots of feedback from teachers about how the air, the atmosphere, the ambience of these schools is very calm and ordered and organised, and that the air feels very fresh and comfortable. So for the last 5 years, I've been involved in developing the Edinburgh studio for Archetype in Scotland with various other members of the team in Archetype. I'm really focused on developing schools alongside new energy targets that have been set by the Scottish Government. So Bethania referred to some of these in my introduction. They are the Learning Estate Investment Programme funding requirements, and an important funding requirement is being able to achieve a certain energy metric. So these are the educational buildings that we have been working on across Scotland over the last couple of years, and their corresponding energy use intensities or final energy targets that the buildings are aiming for. All of these projects are Passivhaus projects as well. Two of the projects in particular have been used as pathfinders back in 2020, 2021 for the Scottish Government Net Zero Public Sector Building Standard, which the latest version of is also encompassing construction carbon as a target, as well as having operational energy as a target. So very aspirational, ambitious guidance documents coming from Scotland, and the very reason we set up practice up there was to respond to those really ambitious climate targets and the climate activity that's going on up there. And the latest information on and topics that are happening is around creating a Passivhaus or equivalent standard for all new housing in Scotland from 2025. So more on that through the Passivhaus Trust if you'd like to know more. So what is this outcomes-based funding? What is it based on? Well, it's about allocating performance of the building after it's completed. So instead of just handing out taxpayers' money to the financial directors of local authorities to spend on these capital projects, they're actually looking for a return on those commitments financially. So there is a requirement that over 25 years, the building's maintained to a condition A or B rating, which also involves in the energy consumption being retained at a particular graded level to avail of a certain percentage of funding. So you can see here that if we're below 67 kilowatt hours per metre square per annum, or between 67 to 83 kilowatt hours per metre square per annum, we will obtain 100% of the energy funding from the capital value of the project in order for it to be built. So that money is released then annually to the local authority client over the 25-year period as an incentive to ensure that that building keeps performing. If we get over 130 kilowatt hours per metre square per annum, we receive 0% funding, or the client will receive 0% funding for that particular metric of energy. So there's other requirements around learning, accessibility, digitalisation. So it's a very holistic approach looking at the education estate in Scotland. We're focusing very much here on the fabric and operational performance. And really, this has been an industry changer across the last 5 years in Scotland. In 2023, the Passivhaus Trust had its annual UK Passivhaus Conference in Scotland, and I'd urge you to have a look at the programme that was set for that to get a sense of the scale and reach of Passivhaus as an energy standard across several projects in Scotland right now. So back to the school that we're highlighting for you today, Riverside. It is a primary school. The brief and client, the brief was set by the client Perth and Kinross Council, and it was delivered by Robertson Construction under a public-private partnership with the local authority called Hub East Central, which is a vehicle for infrastructure and project delivery in Scotland. There was various ambitious elements to the brief from the very beginning. So back in 2019, when the brief was set and the project was commenced, about prioritising the occupants of the building. So this school is bringing 2 schools in the locality together on the one site, both very different schools in different locations within the Perth town hinterland. Health and well-being, so we were right just before COVID, and this building was designed all the way through COVID, actually, online, in fact, through the worst of 2020, as it were. So there was particular reference to how a building might cope in a COVID context post-completion. The pedagogy was a big debate, and something that's really enjoyable about working in Scotland is there's a really open dialogue about educational pedagogy in comparison to the Department of Education schools down south, which are very much cellular kind of corridor classroom typologies. In Scotland, there's a kind of dialogue around open plan, semi-enclosed spaces, multi-learning spaces that vary in size, etc., etc. And that future flexibility then as well, like how that could work into any training changes or learning changes in the future was important. And then, of course, there's the focus on sustainable and locally sourced materials or suppliers where we could as well. So the design philosophy, we'll see some concept diagrams in a moment, evolved around lots of natural light, which is a compliance requirement, of course, really good indoor air quality, views and links to outdoor space. So, opening up corridors so that there's a link to the outside, trying to have a feel of natural materials or recycled materials in the spaces. And the brief for this project allowed for very generous classroom spaces. So again, a real focus on a multi-learning experience. I think the classroom size down in England and Wales, and someone might correct me if I'm wrong, is between kind of 55 to 60 metres squared. These classrooms are 72 metres squared. So the per metre squared per pupil in Scotland is 11 metres squared in comparison to the 8 metres squared in England and Wales. So you get this extra sense of space and quality and flexibility in these buildings. How we moved through the early stage design team appointment, because this was run by Hub East Central, which is a public-private partnership, it actually allowed the contractor to come on board at around the time that we came on board as well. So the Ariba early stages, early stage 1, 2. And that allowed us to work alongside the client and the contractor to really get their client documentation and specifications passive house ready. So it was a committed passive house project. That's what was contractually on the cards to be delivered. And we went through the employer's requirements with the client in a very open, collaborative manner with the contractor to purge out kind of any old kind of guidance and old requirements and layer in passive house and energy conscious requirements through the documents, and, agreed them all and worked together on that basis over a couple of months. The costs, this project went to site just before the market and global volatility at the very end of 2021 that we had. So it probably missed a little bit of that inflationary risk that projects have had since. I'll talk a bit more about that at the end. And there was a requirement around information management on the project. So part of the Learning and State Investment Programme funding also is about having a building that's really robust in terms of its handover processes. And there's a vision that Scottish Government and the Scottish Futures Trust has for education buildings in Scotland, is that all the digital assets that we produce on handover are standardised and regularised across the whole estate, and using BIM and really refined information management to do that. And then finally, we were the passive house designer and also the architect. And, whilst there are many, many passive house consultants out there who are absolutely excellent, I feel really at home and members of my team with the 2 hats on, so that you're the lead consultant and the passive house designer. It allows decisions to happen very quickly and seamlessly, very quick testing, and it just works very well in terms of getting to the very first principles about, in terms of detailing and delivery to achieve passive house from the outset. So this site was in the middle of a 1960s, 70s housing estate. There was an existing school on the site that you can see here is orientated east-west. It was a single-storey school. And there's definitely the argument out there now about retrofitting first and looking at whole life carbon scenarios on these projects. I would say on this case that the school had some of that failure across the estate in terms of the masonry and concrete construction that was on the school. It was just coming to the end of its life. It was single story. And remember, we were bringing two schools together on this site. So we were densifying the site, I suppose, as a sustainability tactic, as well as trying to open up more green space compared to what was there at the start. So you can just see that the primary staff entrance was from the north of the site, and there's a small nursery to the south. And just south of where the school is, there's a collection of like local shops and kind of small scale community facilities. And it was felt there was a little bit of a missed element of creating a sense of place in the middle of this slightly more nondescript housing estate, where there wasn't a kind of central anchored space bringing the community together. This also brought along various phasing challenges. So as part of the rebuild, you will see how we dealt with that. So we went through a variety of different massing and scaling options, all with different pros and cons in relation to form factor and surface area and orientation. And you can see that option 4 to 6 at the bottom, we were coming more down towards the south of the site and trying to create maybe a bit of anchoring to the south of the site, as well as optimizing the orientation for us for Passive House, which works a little bit better if we can orientate these smaller primary school buildings to north and south. And you can see that option 6 is where we sort of ended up really, where in the phasing we were going to have to demolish the nursery. In the nursery, we're going to have their temporary needs accommodated on the site elsewhere. That allowed us to get this nice southern positioning that also acted as a little bit of a catalyst for planning in the area to maybe in the future look at revitalising that little community centre that we spoke about that was just south of the site as well. So this allowed us to have the main student entrance and approach from the south. We still have some staff entrance facilities to the north as well. There's obviously a reduction in car parking, looking at the client's net zero climate ambitions as well. There's early learning and ASN or learning needs provision, separate secure entrances as well, and then separate access for deliveries and services, etc. And there's an emphasis on playgrounds and different themes of playgrounds and links to those playgrounds very strong on the ground floor all the way around the building as well. And what we did was we stepped the building where we had the higher hall to the north, so it wouldn't overshadow the building per se, and the smaller single-storey nursery to the south. So you can see here the kind of concept drawings at the start when we're in REBA stage 2, where we have a clear story, the kind of classic archetype sectional building profile, and the nursery to the south, and the hall and kitchen and kind of services provisions to the north. The form factor on this building was a little bit higher. It was about 2.6 by nature of its two-storey requirements and the more linear layout that we needed to go with. And you can see the glazing ratios here aren't really the most optimized for Passive House, but obviously with the form factor and installation specification and the obvious requirement for glazing in classrooms that are on the north, we had a higher ratio of glazing on the north than maybe ideally we'd like, but again, it's totally acceptable and possible. We need to be mindful of the glazing on the east and west ratios, and the orientation lended itself favourably to keep those percentages quite low for us as well. And you can see on the section at the bottom that through a little bit of a VE process then, we did unfortunately lose the clear story, but we were able to replace them with a series of punctured roof lights, which we'll see as we move through the design. So we talked about the Learning Estate Investment Programme funding requirements, and we talked about that energy banding between 67 and 83 kilowatt hours per metre squared per year. When we got to the end of REBA stage 4 and we finally did our final revision of the PHPP software to see where the building sat, we were at a final energy demand with heat pump efficiency, so the renewable contribution of heat pump efficiency added in at 53 kilowatts per metre square per annum, and the corresponding without heat pump efficiency at 62. So we're below the metric for the funding. And the idea about being a bit below the metric rather than sitting in that grade A banding is that we're allowing the client a little bit of tolerance, especially in those first few years, in terms of user behavior, additional energy, and just refining how they get to know the building, and just allowing that bit of flexibility. And also because Passive House allows us to aim for lower, and Passive House was a contractual requirement. The construction of Riverside began in the early REBA stages of CLT, and unfortunately we went through an extensive VE process, an affordability cap assessment, as many projects do, as I'm sure people on the call are at pains to know themselves, where the decision was made to move to a steel construction. Now in 2020, the end of 2020, early 21, this was, never really looked at or considered for schools. We have had many steel frame non-passive house schools and lots of other buildings, of course. But in terms of trying to get to passive house levels of detail and quality assurance, there wasn't anything at this scale that we could refer to. So we use this diagram to generally explain that airtightness and kind of robustness and continuity of materials can be slightly easier with planar surfaces such as concrete, CLT, even timber frame, versus the very elemental planar 3D kind of componentry of steel frame or SFS or light gauge steel infill construction. So we have a real kind of potential challenge that we're asking the contractor to do in relation to delivering really exemplar details. And we have a corresponding difficulty. So as a result of starting the Riverside project and some of our other projects in Scotland that are steel frame or have a hybrid of steel frame and other construction, I authored a technical position paper with a number of other really great experts across the UK, and that's available on the Passive House Trust website, Steel and Passive House Construction. And it really is aimed at clients, clients, design teams and contractors to really give just an overview of some lessons learned, watch points, further areas that are developing in the sector. And it is a position paper, so things will be likely to change over the next few years and as more lessons are learned, but hopefully it's out there as a little bit of good guidance for design teams, clients and contractors when approaching passive house or high performance steel frame buildings. So some of the challenges I'll just run through quickly. We have movement joints that we need to be mindful of, whether that's in the outer board. So you can see here we went with a little bit of a blended frame approach. With Riverside, we have a steel frame with some precast floors, a steel roof, a trapsid roof, so very typical construction. And then we have an airtight board, a weather board on the outside with an airtight, wrap-tight product wrapped all around the building, which you'll see in some photos now. Outside of that as well, because of the form factor and because we were in Scotland, the climate's a bit colder than in many other climate areas of England and Wales. We've had to add a bit of additional insulation within the SFS infill, as well as the outside 180mm, which is a rock wool insulation. So we had various compliance requirements around fire protection, non-combustible materials, where we could put insulation when we have intumescent coating on steel frame. The coating has to expand, therefore you have to leave a cavity, therefore that means there's thermal bypass around that building member. So we need to be very considered of that at early design stages to make sure we account for all of those thermal bridges, as well as assessing for any condensation risk. As I said, steel frame is very complex in terms of all of its junctions, and we can see that there was quite a lot of complex junctions that we needed to fully insulate around and make sure there was no gaps or any risks of thermal bypass, especially because we had to insulate within the infill SFS area. Ideally, we would have left this completely uninsulated and just insulated on the outside, but that was the nature of how the detail evolved. We also had some innovation around 3D connecting for thermal bridge free detailing through the parapet. So you can see we put in a 50mm Armatherm thermal break at the bottom of these steel parapets, so we could very simply wrap the insulation up and around and create essentially a thermal bridge free detail at all these locations. Air tightness then, so you can see pictures here of the wrap tight, which was put onto a cement board. Originally we started with the cement board, which has an integral air tightness itself, and felt maybe we can just tape the joints and work with the cement board. And I know there's other projects in the UK looking at that. Again, Wrap Tight and Proctor were a local supplier to the area, and were great and very hands-on in terms of coming down to support. And it was the contractor Robertson Construction's first passive house project. And I think ultimately in collaboration with them and the client, we felt that even though it was an additional cost, it was a more robust approach to the air tightness, and the contractor felt more comfortable with it. And you can just see some examples here of how the contractor QR coded and referred to, I think there's 115 penetrations across the whole building. And you can see the workmanship there on the right hand side of the insulation, the air tightness, and the penetrations all coming together there around the door. Sequencing is something that's really important to us. So I believe there is architects out there who don't believe that sequencing is something we need to think about. I would disagree. I think if we design a 2D detail, we should absolutely know how it goes together in 2D and actually use these sequencing details to help the supply chain understand and actually get some maybe better ideas from the supply chain. And that has happened on this project in relation to maybe how some products came together and how we focused on the order of sequencing to best suit the site and the site team. So it's a two-way process for us exploring the sequencing to know that something's buildable, and then also to get that feedback from the supply chain and to know how it'll work. And as I mentioned, we went with a blended steel frame approach. And in the steel position paper, you'll see my caveat and caution to the industry about using this approach and being very robust about where your VCL, your vapor control layer is. The air tightness layer in this case was separate to the VCL layer because we felt it was too complicated and too much risk to put on that internal surface. Whilst also having to treat the VCL layer almost like an air tightness layer as well anyway, because of the risk of having the insulation in the middle of the steel frame as well. And we always would want and desire a good thickness of insulation on the outside of the frame. So we had 180 mil on the outside and about 154 mil the width of the steel frame on the inside. So there's always that little bit more on the outside. And again, we undertook hygrothermal simulations of these build-ups in WUFI, particularly for the north and northwest facing walls, and we were left with very, very low condensation risk in those particular areas. And we had to produce that for passive house certification as well. So again, just rattling on through steel frame. You can see the complexity here with steel frame, post filling in on insulation, 3D connecting details, how, working with the contractor to start filling in some of these before they get installed on site. So the SFS rails, for example, around the primary steel frame, how can anyone get their hand in there to insulate properly? So they need to be taken back out or pushed down through the construction detail, filled in properly with lots of space, and then pushed to their corresponding locations, as you can see on the lower images. So just lots of pre-thinking. Sometimes insulation needs to be on site before you think it does, before you sequence for the whole building to be insulated. And again, trying to learn that process and work with the contractor to understand how that comes together. So this is just an aerial view of the project as it progressed. You can see that here's the roof on. It was a CalZip roof, so again, very much typical construction. But again, the sequencing of how it was put together, where there was wet insulation, and if it couldn't drain, we requested for it to be removed and replaced. And the contractor was always very good at monitoring that and also redoing elements of work where things weren't acceptable. You can see the roof lights poking through there as well. So this is one of the primary internal spaces on the first floor, the design intent. So you can see that there's very open transparency to classrooms, the P5 classroom on the left-hand side there, and some open plan classrooms on the right, so for multi-blended learning, and quite a wide corridor. So not a very small corridor, not at minimum requirements, but a wide corridor that has some provision for small multi-learning as well as the locker and storage spaces for the kids. This is it through construction, so we can see the fireproofings come up onto the first floor slightly, the trapezoidal roof, those lovely details. You can see the blue VCL on the lower base rails of the SFS, ready to take the next layer up to keep that continuity, and the lovely glazing that was in actually each of the classrooms to get that good daylight factor. And this is the completed reality, where we were lucky to be able to work in some of our nice acoustic recycled glass wool, and that sense of openness and materiality and calm, I believe we were able to hang on to, even though we did go through quite a few VE processes and working with current market challenges with subcontractors, etc. So what was the key? What was the main thing for us moving through this project? Well, it's the same on all our projects, but I think because this was the first time a steel frame was attempted at Passive House in Scotland, it was the first primary school to be done in steel frame. It was quite ambitious of all of us and quite required of all of us to work together really closely. We established really clear communication lines. So we acted as obviously the design team lead as well as the Passive House designer. And we made sure that if there was any substitution proposed or any changes to anything, that we had a very clear workflow back to the main contractor, but also the Passive House certifier, Warm, who worked really closely with us as well as one of their first steel frame Passive House schools, to ensure that all the material got to be compliant and installed correctly. We also drew up some posters and information requirements around the site. So very much like you'd see health and safety information on the site, on a site. We worked with the contractor to develop a series of posters highlighting and educating. So if, contractors were out having a break in their outside little terrace area, and they felt so inclined, they could just read a little bit about what this project was, what Passive House was, what did that mean for them, etc. We did toolbox talks. So the very first, you can see the kind of COVID separation we had here right at the very beginning of the project, early 2021, where we went through what good and bad examples of installation quality were. So very much what you learn about Passive House as you move through the Passive House courses, and looking at how that was implemented on site, how we'd end up accepting details. And what happened with this contractor is that we worked with him at one corner of the building, and if the materials and the compatibility and the workmanship was okay in that particular corner, he was able to then go and give the okay for the rest of the building to be completed. So on larger projects, sometimes that's done on a sample or mock-up building, where you can kind of agree the detailing and the level of quality and workmanship. But this worked quite well with this contractor and his supply chain in relation to approvals. Just a little bit of an example of like some of the services pop-up evidencing. Looking at you'll see just around the right hand soil vent pipe there, a circular cut in the insulation, not just a square cut. And you can see just other simple evidencing, like, is the insulation that we have on our drawing and specification, did that arrive on site? Yes, it did. And what is the thickness of that insulation? All of those things we need for the certifier. Other really innovative elements of this project as well were around clash detection. We had one of the little robot dogs. I think it was in collaboration with Heriot Watt University that walked around, which is kind of very exciting to see. One of those dogs walk around site once he didn't get his feet caught in any of the scaffolding. The use of QR codes, the live building information modelling, and looking at exactly where all the services were and where they were on site. And sometimes, as you can imagine, especially with services, they just didn't end up being in the right location on site for some reason. But we were always able to track and respond and create a delivery on that as we moved through. So what were the insights gained from this project? Well, the early design team appointment, and I would argue, and we've delivered buildings in various types of contracts, that actually having the contractor on early and partnering with us was a benefit and not a disadvantage. And I know a lot of the design industry would maybe see that as a disadvantage, but I think we were able to work together and understand each other's viewpoints much, much better. We also had a really, really great client who, almost had weekly or bi-monthly meetings with us. We established a close relationship with the client, all with the contractor's involvement as well. And it very much didn't feel like a traditional adversarial D&B project. It was very much honest, open, transparent, and we'd have daily calls with the site foreman and Passive House champion, for example, where needed, especially through COVID. It really worked to our advantage that we were the architect and the Passive House designer, so we were able to have the architect on the team, Charlotte and Sam. Charlotte was the main PHPP lead on the project after the initial stages, and as she's so embedded in the drawing, she was also able to immediately pick up on when something would affect PHPP, and she's in every single meeting, design team meeting with the project. So we were able to pick up on the nuances and the risks as early as we reasonably could. There was a lot of investment in upskilling and knowledge sharing. So those toolbox talks, it wasn't just for the contractors, the client would pop along. We educated and upskilled members of the design team. The M&E engineers, for example, were very hesitant about how we were proposing the ventilation system, working gently with them to get the right results on that as well. And the same with the engineers for the steel frame, and trying to better understand how that steel frame impacts Passive House was really helpful to them. And the sequencing ultimately is what led us to getting to the building that we can see today. And it's really satisfying as an architect to always see that the projects that you design and see in 2D and 3D in the studio is actually what gets more or less built on site. And even though we did have a VE process, so there's some things that we did have to change as we went along, but ultimately overall, we've been able to deliver a really great building for the client. Lastly, steel frame is quite challenging. My preference would be to not build in steel frame, but that's just because of the other considerations with steel frame that I'm not covering today around whole life carbon and the fact that we haven't really decarbonised the steel frame industry yet, and we don't use enough recyclable steel. Anyway, there's a lot of I could have a whole other presentation on steel frame. But it does have its benefits, and it does have. We've been able to deliver a quality building, whilst dealing with some of the complexity of the steel frame. So where are we right now? Well, the building's been occupied since July 2023. The final air test was 0.53 air changes. So our interim test was actually 0.3, and I think we lost a little bit of leakage around the windows, in particular, and thresholds. And when we fully installed the MVHR, I think there was a little bit of leakage around some of the louvers. So I think just something to watch for. We still more than complied, but really you need to be targeting a much lower air tightness test result in the middle of the construction to allow for a little bit of variance towards the end. We just have a couple of bits of evidencing to still deliver. So we're just revalidating hot water runs in the building. And there was a couple of queries over the technical requirements around the thresholds of particular doors, etc. So we've had to kind of go back and forward a little bit with the supply chain on that, which is a bit of a shame because we really were expecting to have this certified last autumn. It would have been one of the quickest certifications we've had. So yeah, bear with us. We're still getting there with that. We've issued and I've authored the steel technical position paper. We've got lots of lessons learned for our other projects in Scotland. It was a new sector to us, new supply chain, new design teams, and we really enjoyed. We really learned a lot as well through the process, and we've found really great people, really collaborative people to work with. And I'm just going to go into a little bit on the building performance on the project. So we've just come out of a 3 or 4 month post-project review period as required by the funding requirements as well, which I forgot to mention. Actually, part of the funding requirements for these new schools is that their post-occupancy evaluation is carried out on the projects for 12 to 18 months post-completion, which is really amazing to have that mandated into the projects, and there's particular criteria that they need reported on. So in the kind of limited, the project was finished in June, occupied in July. Then there was the school holidays in Scotland, and the project then, was the building was filled again then from the middle of August. So we chose to kind of have a summer period this year just gone of like the 14th of August to the 1st of October. So again, we had quite a hot September actually, and there was a little bit of heat in August. So it was quite good testing of the building and the users of the building. And then 9 weeks of a winter condition. So again, and we probably had some colder weather even actually after the 1st of December, but I think they were still reasonable in the short time frame that we had to be able to test the building. So I would caveat that these are just preliminary findings, and I'm really happy to share them with the team today here and the audience. But we obviously are waiting for the full year to be done, the full report to come back to us. So something I haven't mentioned, in another challenge in schools is designing around all of the small power that's needed in schools. So, the smart boards, the kitchens, the ventilation systems can, they're quite significant in some of the larger schools. Things like sprinkler tanks, hot water, all of those things have quite a lot of power consumption associated with them. And we have a graph in a minute to show you how that compares. So what we did at design stage versus what we had in the end. So you can see that small power lighting is quite a high load because of the time of the year that we were monitoring the buildings. We expect that to average out over the next couple of months as we move back into the summer. You can see the 3 big areas there are lighting, the kitchen, and the small power load. So all the smart boards, all the appliances, etc. in the building. And you can see just a quick comparison here, what the estimated annual consumption is at that particular point in the school, because we're obviously metering everything in this school as per the funding requirement. I've mentioned already about the lighting. amazingly, the small power estimate is really close to what we estimated at REBA stage 4. So I'm really happy with that, because I think there's a lot of nervousness in the industry about how small power affects building design, especially in Scotland. So this is really evidence that if you do it properly through the design stages, there shouldn't be that lack of confidence or worry about small power. And we can just look at here, the sprinkler contribution is about the benchmark, maybe a little bit looking at the trace heating as we come out of the winter. And the meals is based on 15% meal uptake. But again, going forward by 2025, Scottish Government want to provide every secondary and primary school student a hot meal in every school. So that will change the demand in the kitchens. And we've been liaising via the Passivhaus Trust with the Passivhaus Institute on this, because actually meals are considered differently in different countries in different educational contexts. So we need to work through that a little bit more. This graph, I just want to briefly touch on. The yellow bars just show the range of CO2 at various points, not against time. But you can see the grey and the orange dots. This is for the summer period. We can see that the CO2 concentrations on average in all of the classrooms and spaces in the building are much, much lower than the 1,000 parts per million compliance limit we need for the ventilation. To the extent that potentially, particularly in the winter time and in the summer, maybe we can start looking at the flow rates of those rooms and see, can we maybe save even more energy, but obviously being mindful of any overheating risk that goes alongside that. So that's been really phenomenal feedback in the first in that 6-week summer period that we've looked at. In the 9-week winter period, we can see that we just have, again, very much the same range of CO2 concentrations. And we can see that the nurture room on the right hand side of the graph got up to, the range went quite high at one point, but for less than I think it's 0.5% at the time. It was just to do with very high occupancies in that classroom, in that nurture room, and it's kind of oddly occupied as a room. It's not as regularly occupied as the classrooms. And then the hall actually was so quite well ventilated the whole time. And again, the hall is somewhere we can definitely reduce airflows, and that's just about design as well, learning that actually maybe if we could have availed of cascade ventilation in the design approach more, but we did have a nervousness from the engineer and the client about doing that. The hall actually has its own MVHR, which we disagree with. We don't think it actually needed that, and actually, you know, we'll go back and work at the airflow rates as we move through the POE period to not send as much energy into the hall MVHR. This is just a bit of a pullout of all the temperatures that were across the 15-week period that we had, so summer and winter. And the green, red and blue at the bottom are basically saying if something was hot, okay range, or cold. So we're down to between 17 and 25 degrees, which is the Passivhaus overheating limiting criteria. We can see that, you know, it's not a really flat graph, but we have a really nice steady profile of temperatures there, as you'd expect in Passivhaus. Now, the kitchen was the only abnormal in that for a couple of the weeks, which I think is to do with just a commissioning element on the MVHR, as far as I'm aware from the team, because I'm on maternity leave at the moment, that's been sorted out. But again, really good that this post-occupancy review at this point is picking up some of these issues. And we are going to some of the other individual rooms just to ensure that it is that everything's going okay. And you can see that, you know, there's also behaviour that feeds into that. So we had some interesting times in the first few weeks where we were recommending opening windows at night as part of the purge ventilation strategy. And whilst the teachers were leaving the windows open at nights, the cleaners were coming in later and closing the windows. So again, once that was communicated, the temperature then settled right down at night time, because obviously the natural ventilation was part of the ventilation strategy through the louvered windows. So just back to, are we meeting the funding metrics? So this is what we said at REBA stage 4. We were aiming for about 62 kilowatt hour per metre squared core hour. Currently, projecting on the information we have so far from July up until December, we were looking at 50. So the building's performing better than we estimated at design from an energy consumption point of view. And that's notwithstanding all the little things that we've picked up on and said we want to tweak, we want to fix, we want to just see why that energy consumption is high in X, Y, or Z place. So this is really, really exciting. And I mean, I am caveating that it's still not the full year yet, but we know this client's going to get that energy metric funding. And they're well below their A grade banding requirement for 100% funding. And we're just really pleased that, again, it's another building that's actually performing better than the design stage, rather than what the industry standard is, which is the building's performing much worse than what we estimated at design. And this is just a quick comparison against some of the SIPSI good practice guides. Now, I would caveat that obviously Riverside is an all-electric building. It's utilised heat pumps, so there is no gas in the building. So we're just looking at the total figures here, CIBSE good practice, CIBSE typical. The LEAP requirement then for funding and where Riverside is currently sitting, which is really brilliant. And just to leave you with a quote from the head teacher at Riverside, who's just been so happy and overjoyed with the building and the coming together of the two schools. The pupils absolutely love it. Enjoyed following them on Twitter over the last year or two as they went on site visits and really found out what their new school was going to be like. And we're really happy to have worked with Annabelle and the team to deliver a project that I think everybody's really happy with. And ultimately, that end user is the person we're trying to satisfy at the end of the day. They're in the building a lot more than we're ever going to be. And we've just had really good response from everybody. So thank you very much. That's me. I'll hand you over to Bethania, and hopefully, there's still a few minutes for some Q&A, and I'll try my best to answer any queries you have.
Thank you so much, Anna-Marie. It's been a great presentation and an amazing project, very holistic approach. And I think we have all learned a lot from it. And I will jump to the questions because we have several questions. So first, how was domestic hot water done?
Okay. Hi, Jonathan. Domestic hot water was done by instantaneous hot water heaters with one hot water cylinder in the kitchen. So we looked at instantaneous so that we reduced the traveling of hot water and hot water pipework around the building. But what happened was, and why we're still correcting the runs or lengths of pipes for passive house certification, is that when they actually installed the units, we had associated and agreed about a 1.5 meter length of hot water per instantaneous hot water heater, that would be the maximum. And some of them ended up being a little bit longer than that, just by way of how they were installed in the classrooms. We chose that way of going with very small storage associated with each classroom, and also but a slightly higher watted output on those hot water heaters, so that we have good and quick recovery rates. And we actually worked with the subcontractor FES and the client when the project was built to reduce the overall volume again by about 30% from the design, because again it was felt that there was too much hot water being stored in the instant water heaters, if that makes sense. So we're able to further refine it. So hot water is such a big area that needs a lot more challenging and drilling down in in the built environment. But yeah, hopefully that answers your question. So instantaneous hot water heaters with a cylinder and an immersion heater just in the kitchen for those higher volumes.
Thank you. So second question, what was the product used to create the thermal break at the parapet again?
So it was an Armatherm F4, I think 500 thermal break. So that was a rigid thermal break that would connect steel to steel components, and we worked well with the rep to get the right specification for that and the sequencing and how that related to the air tightness as well as the insulation layer.
Question: if you use decentralized ventilation, you could have automatic demand control on a room-by-room basis. Recent tests by some of the main contractors in Scotland have shown 0.3 meter cube per hour air leakage on each ductwork penetration, which is nothing.
Yeah, absolutely. I mean, I think, Jonathan, we've crossed over before, and we've done a few assessments with different engineers on the benefit of centralized and decentralized ventilation units. So that's a whole other presentation probably, but absolutely, like, the quality of the decentralized units are getting better and better all the time. And Jonathan himself, you sell the certified passive house unit now as well. From a kind of cascade ventilation approach, and from an energy use approach, and from a backstop ventilation, how a decentralized unit works on its background setting, as it were, when we're looking at the whole energy and context for the building. The centralized ventilation can have a slight edge over it depending on how it's designed, and we also just wanted to de-risk the amount of penetrations in the building. So it's really good to see that other projects are getting to a very, very low point of air leakage with so many penetrations. But absolutely, I mean, there's definitely great projects out there at the moment using centralized and decentralized. And I mean, again, demand control on a room by room basis. I think we were looking to reduce the teachers' involvement with how to technically run the room, that was coming from a centralized point, and the use of cascade ventilation as the approach in this school, where the supply air is sent in and then the extract air is just pulled out via plenum into the corridor, just allows the same constant volume at a very low airflow rate to be pumped to all the rooms to achieve those CO2 levels. So again, it's that complexity of how complex do we make things, because we have to go down a different route in one of our other projects because it's a secondary school, so a little bit more complicated to ventilate than a primary school.
Interesting. Was there any concerns from the local authority regarding leaving windows open, assume tilt function at night for purge ventilation versus secure by design? Or were the only operable windows sitting behind SBD compliant louvers?
Hi, Melissa. So the purge vent are behind Duco secure vented louvers. The scheme itself wasn't signed up to be a completely official secure by design scheme, but obviously the specification lended itself to being having secure louvers on the ground floor at the very minimum, secure by design stamped louvers, as it were. So we use the Duco grills, which allow still quite a good air transfer through for airflow. So I think the cleaners probably had a bit of a concern about the night security, because they were going around closing them all after the teachers left them open as part of the user strategy. So that was really interesting. So yes, the only windows that were open at night were behind secure louvers to allow that purge ventilation to happen at night.
Right. We're still getting more questions. What are the issues encountered at the threshold detail in obtaining passivhaus certification?
So we worked with a company, like many projects are in Scotland at the moment, called Metal Technology, who have a variety of really great passivhaus certified products and components. And what we were looking at was the connection between some of their thresholds and solid panels on doors. Or the psi value between glazed sections of window and how they connected to the threshold elements of those doors particularly. So the doors were slightly lesser quality than the passivhaus certified windows, as it were. So we were having to kind of accommodate and do lots of extra tests. So really the position at the minute, Callum, is that we're asking the supply chain still for more calculation evidence to verify that the doors aren't going to be a condensation risk. So we're pretty confident that the doors are fine, and we're working with Metal Technology and the subcontractor to get that information. But it's a classic thing of, everyone's gone off the site, the subcontractor's onto the next job, and we're left, and this is our certifiers left and the contractors left trying to chase down this information. So it's just so important if you're signing off projects that you get the windows signed off with all the information up front. And unfortunately, this psi value information we got quite late in the supply chain, when actually they were very good at providing lots of other information. So just really, really be absolutely anal in getting information up front while you're signing off drawings. Do not sign off drawings to come to site unless you have all the data for those windows and doors, because you will be left in this kind of delayed process at the end. So we're confident, we're not worried, but we're, that's another lesson learned for us, to just, again, not leave data as much as we were chasing it for a year. It leaves people at a little bit of risk if you don't have the data in front of you and signed off before the products arrive on site. So it's a big ask, because the industry is not used to providing that for you, but it's one of the big bits of evidencing for passivhaus is the windows and doors, as anybody who's been through the process will tell you. And the earlier and the more steadfast a workflow you can put in and working with the contractor to get his supply chain to respond in the right way, the better.
Thank you. Continuing with windows, I have another question. Beyond the size and
I think I've
sorry,
just
I have another
answered that.
one. This one. Beyond the size and orientation, what is your main priority when designing windows? Do you have any type of hierarchy or favorite design? How do you balance connections to exterior and daylight with massing and energy efficiency? Do you have any type of hierarchical approach?
So I think the not that we avoid floor to ceiling windows, but we really have learned from our own schools at the very beginning, where we had floor to ceiling windows in some of the teaching spaces, that increases overheating risk on our own projects. So we've learned our own lesson, as it were, by that. And we've also learned through that process that when we try and connect to outside, that there might be other ways we can have a lower sill, but we don't lower it all the way to the floor, for example, or we can have particular kind of feature windows that focus on a lower visual element as you look outside. But of course, we're limited in classroom design by minimum required daylight factors. So we have to hit that as well as hitting all the comfort criteria on the inside. So again, I suppose the current iteration of windows that you see on the Riverside project are probably our latest kind of typical approach to window design in schools, where we have louvers that are secured for night venting on the left and right hand side of the classrooms, and we have a series of smaller windows that can be physically and manually opened during the day at the bottom, with an array of fixed windows on top. We try and reduce the amount of mullions we have as much as possible without increasing the kind of structural weight or requirements of the window itself. I think it's about having a variety of openings, trying to reduce the mullions as much as possible, ensuring the occupant can actually get at the windows and open them, and that the louvers, yes, they have an impact on daylight factor, but they have other benefits for ventilation. And I think it's very important for your windows and your M&E engineer to model them properly in the IES software when they're looking at their own energy performance, so that you're really assessing the overheating risk. Because as you might know, the PHPP is an Excel-based software. It's based on 3D algorithms for lots of different design parameters, but we do need to separately isolate and test in IES and other software. And what I found commonly is that when you're trying to test windows and design of windows, that the IES software sometimes isn't as exact as you would like it to be. You know, it's a little bit, you have to understand how to get it to model things properly, to be able to understand what the ventilation requirements are like. So yeah, I think if you look at our earlier schools like Wilkinson and see Harris Academy, Hackbridge, you'll see this kind of an evolution of window design that broadly follows that detail. And maybe it might evolve again. You know, we might get feedback from this school that there was something about the windows that they don't like, or maybe there could have been something technically we did differently, and we try and take those things on board then if we felt we needed to.
So you have an evolution. You have had an evolution in the Windows design.
Absolutely, yeah. Like we've learned our own lessons, and we've done POE on other architects' projects and learned lessons there as well. And there, it's the elusive, you know, windows in education buildings are trying to do so much. You know, whether it's like trying to stop people falling out of them, ventilating right, getting the right daylight, being able to use blinds properly in them. You know, they really are a challenge in themselves. And look forward to seeing other passivhaus projects in Scotland as well perform with how they've designed windows, just to see how we learn as an industry how it works, because even in different education sectors people will use it differently. And I think just to finish on that, we did go down the actuated window route with some of our earlier schools, and we found that teachers really didn't like them. You know, windows were opening and closing like without them controlling it. And just in reference to the ventilation earlier as well, we felt like the teachers really like being in control of their surroundings, even though we don't want them to have to interfere too much with their surroundings. But for them to not feel they can open a window, or they feel something's automatically happening in the background for them, that's not really, you know, that's not a nice environment for them. And that can, it's that feedback then that we've gone back to manual opening windows and manual leaving windows open at night behind secure louvers, rather than having like a system telling the building to do that. So yes, you're bringing in a bit of human error, but it's either, you know, automated error, which has its own issues, or human error if they forget to open a window. And I think, you know, it's about engaging with buildings at the end of the day and making people feel like that they can own or kind of access a window and access their environment like they would at home.
We are already up to, but can I ask you a last question? So do you have an experience of any offsite, so prefab passivhaus project? What materiality was used, or you think it could be potentially used for best passivhaus performance?
Oh, that's a very big question to end with. So we don't have many MMC schools. We've looked at a couple with the Department of Education down south, and we have worked a lot with CLT and prefabricated timber frame panels. I would just say most, and again, this might be a dangerous statement, but I think most production lines for MMC across the UK right now are not set up to be at passive house levels of quality in terms of their installation or creation of the paneling. There is a lot of interfaces that are, need to be considered in relation to thermal bridging, fixings, and how things are clicked and connected together. I think on the small scale, there's a couple of suppliers I think doing really well on achieving those things, but on the big production lines, the big ambition to roll out buildings off factory production lines, there's a lot more to do to make sure that the quality of the detailing is robust. So there's a huge amount of advantages to it, and we'd love to work more with suppliers rather than even build a school out of MMC. We'd like to work with the producers and designers of the factories in the first place, just to try and build in that quality into the paneling. But yeah, really excited about that industry and what it can do. But we need to be mindful of the pitfalls of like throwing buildings up really quickly, as we've seen from the 60s and 70s. When detailing isn't really robust enough, we're going to get kind of roof and wall failures in the next couple of decades, and especially when we're looking at high levels of air tightness and high levels of insulation.
Great, thank you so much. Thank you for your time. Once again, thank you for the presentation. It was very insightful. Thank you everyone for joining our Share Your Green Design Masterclass, for all your questions. As usual, this session will be posted online, so check out our website, shareyourgreendesign.com, and subscribe to our channels to keep up with this and other content that we are constantly sharing, such as the latest projects, news, research, events, competition, student work, and job adverts. If you have projects or research that you want to share in our platform, please get in touch with us. And if you have any comments, ideas, or just want to collaborate with us, please get in touch as well. Thanks everyone, and see you again soon.